Hey, welcome, everyone. Thanks very much for coming today. It's a busy time of year, what with mid to late December and final exams and grades and stuff like that. But thanks very much for taking the time to join us here. My name's Alan Rossman. I teach in the statistics department at Cal Poly in beautiful San Luis Obispo, California. Let me share my screen and remind you why we're here. I think you know why you're here, but let me share my screen. I just have a couple of slides to share before I turn it over to the panelists. So today we're here for a panel discussion about using student activities for learning statistical concepts. So we have several panelists who will be joining us today to talk about their implementation of activities in introductory statistics courses. Let me remind you, maybe you were here, maybe you weren't here for some of these virtual workshops that we held back in second half of September and first half of October. But we had a series of 5 workshops where each presenter described and went through an activity that they use with students. And then we had a group of participants who implemented one or more of these activities in their class since October. And today we have a panel discussion where 6 of the people who implemented one or more of these activities will tell us about their experience. So here are the panelists that we have ready to share today. I'll ask each panelist to introduce themselves when their turn comes. I'll ask them to tell you, obviously, who they are, what institution they teach at, which activity they implemented, and what type of course they implemented the activity in, whether it's a course for a particular group of student majors or a general education course, or whatever the situation might be. And we asked these panelists to consider 6 questions, and each of the panelists has agreed to focus on one of these 6 questions. The questions are what I think you see on the screen now. How much did you modify the activity that was presented for use with your students? What were the main characteristics of how you implemented the lesson? What topics had students previously learned prior to the activity? How different was the activity from students' typical class experience? How do you think students responded to the activity? And what challenges did you encounter with implementing the activity? So these are the questions that the panelists will be discussing today. And I'm pretty sure we'll have time for Q&A at the end. And we'll probably have time to interject with questions for each panelist before we turn it over to the next panelist. So without further ado, let me stop sharing and ask Heather to go first.
Hello, everybody. I'm currently in Columbus, Georgia, and it feels kind of like spring here as well. I teach at Auburn University over in Alabama. It's about a 40-mile drive from where I live. And it is a very large university. Our incoming freshman class this year was over 6,000 students. The lesson that I chose or I implemented was the stub lesson, does rinsing with pink artificially sweetened solution improve running speed for paired data? The course that I implemented this in was our only really undergraduate, well, low level, under level statistics course, Stat 2510, statistics for the biological and health sciences. It's mostly pre-med, pre-nursing, pre-dent. There are some wildlife and fisheries students in there, but the core, I implemented it. I have actually I have 4 sections of this course, and I implemented it in an online section, 2 sections that were in a large lecture hall type setting, and 1 in what we call an easel setting, which is engaging in active student learning. So the tables are round. But the question that I am going to address is how did I modify the activity to suit my students? And so this activity, but for pair data, we do in our last unit. And I actually did it before we have 4 units. So I did it before the 3rd unit exam. Because it turns out to be single sample and unit 4 is 2 sample. So anyways, so I did modify the handout, the activity into an out of class portion where I I cut it into 2 parts. And the first part, I had students pair it with readings from their textbook and referring back to some of the things we've already talked about, and then made it an assignment on our LMS, which we use Canvas. And then I could pull up those questions, the answers to their questions before they came to class. I had a cutoff time so that I could actually review them. And then I conducted about a 10-minute discussion about their answers and their responses and the things that we had already talked about and the things that were new because we hadn't talked about pair data and that kind of thing. And then the second part of the handout, I altered it to, we use RStudio on Posit because it's free and it's web-based, so they don't have to download anything to their computer. So I altered the second part of the handout. Instead of going right into the applet, I had them do some investigation of the data in RStudio, so they can use some of the things that we had already learned, and they worked in groups of at least 3. So we had the pink sweetener, the clear sweetener, and then the differences. So we talked about the differences, and so one person could investigate one, and they could work together to come to those summaries. And then I had them go to the applet and investigate what was going on if we're doing this at random. And they actually, because we did the analysis in RStudio first, they kind of knew the first few questions about what are the numbers they're seeing because they had seen them already. But I think it kind of helped to make the connection between the applet and what they had been reading about a little bit better instead of just jumping right into the applet and doing that. But after that, they got into the applet and they discussed in groups, and then we came together to, and one other thing that you might also know is that I have undergraduate learning assistants in the class that well, let's just say the large lecture has just under 200 students in it. So I have undergraduate learning assistants that can help and roam around and help answer questions. And so that's what I did to modify was I split it into 2 parts, part pre-assignment, and then we discussion with that. And then I added the part where I wanted them to analyze in RStudio before they went to the applet.
Thanks very much. Thanks very much, Heather. I'm going to contradict something I said earlier. If you have questions for Heather, I'm going to ask you to hold on to them. Let's hear from all 6 panelists, and then I'll open it up to questions, either to individual panelists or to the group as a whole. But thank you very much, Heather. Next up, I will ask Chatu. I might pronounce it. I apologize for mispronouncing your name, probably. But please introduce yourself. Tell us about your institution. Tell us about the class you implemented the activity in, and take it from there.
Hello, everyone. Nice to see you all here. Yes, I'm Chatu. That's right. You spelled it right. So I am Chaturika Abigail. I just shorten it and use it as a short way so it's easy for everyone to follow me. Right. So I'm in my 2nd year at Rhodes College. So I'm a assistant professor over there. I finished my PhD like 2023, and then I straight joined over there as an assistant professor. So I kind of like taught 3 semesters over there. This is my 3rd semester. So our college is like a private liberal arts college. So we have like classes, the maximum class like size is like 25 students. So we have a statistical minor in our college. So with that, we teach lower level and the upper level statistics classes, and I teach both of them. So I choose my Math 211, which we call as the Introduction to Applied Statistics class for this particular module. And then over there, we kind of go through, the textbook is like the same thing that you all know, the Investigating Statistical Concepts and Applications by Beth Chance and Al Rosman. So I follow that book in my class. So with that, I use this particular paired data and the match design module in that class. So I have two sections for the both classes. I did the same activity following the exploration activity that the paired data design goes with, like, does the rinsing with pink and artificially sweetened solution improve the running speed? That was the activity we did. And I kind of divided it into two sections. Like one is like one part of that one is like take home. The other part is like during the class time, so that I have enough time to do the whole exploration with my students. So I will tell you more information about how I did it in my next question. So that's it.
We have some time if you want to.
Yeah, so if it is possible, yeah. So the first part of that one is I felt like it's kind of the students can read and understand part. So I asked them to do the first part of that material in as a homework study. So they are kind of reading the stuff by themselves and reading it, and I identify what are the explanatory variables and the response variable. They know the concept of the random assignment. They know the paired design. By that time, they know the independent study. So I kind of asked them to do it during the not during the class time, outside of the class. And when they come to the class, I went through the answers with them. So then I know that everyone is on the same page. So I can continue on the part 2 of that one with the simulation study and everything. So when I gave this one as a homework to my students, they already have complete the match pair design lesson in my class as the way I teach them. So they kind of know what is the idea behind a match pair design, and they know how to find the dependency between the two variables if you're having a match pair design kind of like that. So I think with this particular exploration activity, I was able to kind of like establish a solid idea with my students about how do you make conclusions when it comes to a match pair design, because it's very important to identify the relationship between or the dependency between the two variables in order to interpret your results. So I think this worked well for my class.
Thank you very much. The next panelist we'll hear from is Kristen. Kristen, please tell us a bit about yourself, your institution, the class you implemented, the activity.
Sure. Hey, y'all. I'm Kristen Gore. I'm at Willamette University, which is in Oregon, in Salem, Oregon. I'm in my third year, and prior to joining academia, I spent about 10 years working as a statistician at Hewlett-Packard. So it's pretty cool to kind of sync the two life experiences there. I implemented a couple lessons in my statistical inference class, and for reference, we don't have just one intro stats series. We kind of made the decision to split it into two pieces. So one is intro to data science, where it's getting students used to just statistical thinking, and it's kind of like a general introduction into just programming and just how to carry out the data science process. And part of the reason we did that was so that in theory we could go deeper into the statistical inference course, which is the second part of the series. So I taught the first part of the series last semester, and then I had some of the same students in this particular class, along with some others that just were interested in the topic. So it's pretty cool. So I have a lot of students that are sophomores in this particular class, and I wanted to do this lesson during the week in which we did 2 proportion z-tests. And it happened to be around election time. And for many of them, this was their first time voting. So I wanted to do a lesson that, they could relate to, and something that was very particular to some of the measures that were in Oregon. So naturally, I did a lesson on marijuana legalization, and there we go. So specifically, it was looking at how one's favorability in terms of legalization of marijuana was tied to just different demographic groups that they may be a part of. So the main question of interest was, what does your employment status as either self-employed or non-self-employed, is that linked to one's favorability stance on legalization? But to kind of set up the stage for the lesson, I had them just toss out some ideas on, what things could be linked to it. We're not assuming any, causation or anything like that, but what are some factors that you think might influence one's perception on the issue? And that was one of the most engaging discussions I've ever had with my class, possibly because they were like amazed that we were discussing such a topic, but it's college, so it's fine. But yeah, they threw out all kinds of things, and some things that were actually not in the data set that we were going to look at. So the data set that we looked at was the General Social Survey that UChicago has housed there. And but yeah, so they tossed out a bunch of ideas. It was just like a very open brainstorming session. And then I had them break off into groups of 4. And with the seating arrangement in the class, they're already in groups of 4 anyway. But I assigned each of them one of the variables that they came up with and that I knew was also in the data set. And I had them do some exploratory data analysis just to kind of see, okay, what does the data look like? And then we kind of got to talk about, is this within the realm of the noise that we would see if the proportions were the same, or can we visually see a pretty distinct difference that way? So yeah, and then we got into the mechanics of a 2 proportion z-test, which can sometimes be a little dry, but because they were already very engaged with the topic, I held their attention the entire time, so it was a pretty cool experience. But yeah, as far as background knowledge, like I said, they had familiarity with ours, which made things pretty nice at that point. We had covered exploratory data analysis, the basics of probability, and we had covered just what hypothesis testing is and that kind of thing up until that point. So did I answer all the questions, Alan? I'm not sure.
I think so. Thank you very much.
Sweet.
If you have questions for Kristen, please jot them down or remember them. I'll give you a chance to ask questions of any of the panelists once we've heard from all the panelists. So the next panelist we'll hear from is Elizabeth. Elizabeth, please tell us a bit about yourself, your institution, your class, and the activity you implemented.
So my name is Elizabeth Weaver, and I teach at Pellissippi State Community College in East Tennessee. It is one of the larger state colleges, community colleges in the state of Tennessee. And I'd say we have 6,000 or 7,000 enrollment. But the class size is kind of limited to about 20 to 25 per class. So we still have small classes. The class that I implemented the activities in was an introductory to statistics class, math 1530. So it was definitely a lower level intro stats class. And most of my students, well, I had one class of students who for learning support, we do co-requisite learning, which I know is a lot more common now. But so one of my classes was actually a combo class with the learning support for statistical principles, or whatever we call it. I don't remember. But they all did the same activity, and they all kind of ended up with a very similar experience, I think. So my question that I am answering is how different this activity was from, which activity did I do? I did the memory test, sources of variation activity, and it was quite a bit different. They were used to doing some activities, but we use a Pearson textbook, and StatCrunch comes with that. So pretty much any of the activities that we have done up until this point, they had been using StatCrunch. And I was going to change the activity to make it to where they could just keep using StatCrunch, even though the applet is very simple to use. It turned out that it was much simpler than me trying to, especially to get them to do the mosaic plot. It was a very complicated process because StatCrunch doesn't have just a mosaic plot option. You had to go in and do like some pretty special things. So it was different in the sense that they were using the applets instead of StatCrunch. That was quite a bit different. But also just I didn't do a whole lot this semester of them collecting data from themselves. And so I think that was a very interesting aspect of the activity that they liked. They liked seeing that like they could go in if they wanted to, and they could point to like, this was me, this was my line of data. And that was really kind of neat. I saw them comparing like, oh, well, this many people did better than me, but I did better than so many other people. And I just heard different conversations like that where they were actually looking at individual lines of the data, which they wouldn't have done if it was just something from a textbook. So it was different. They were used to activities, but it was definitely different in that sense. And I guess unless there's something else, that's my question.
Very good. Thanks very much. The next panelist I'll ask to present is Arot. Please forgive and correct my pronunciation and tell us about yourself, your school, your class, your implementation.
Hello, everybody. Good to see you. We have a good weather here. Can you see me, everybody?
Yes.
All right. So we have a good weather here. I'm in Holland, Michigan. I teach at Hope College, where Jill Wandersoop and Todd Swanson are from. Well, Todd was until recently. Now he's successfully retired. And so it's a 4-year college undergraduate institution. We have about 3,000 students, and statistics. A statistics class is required for many majors, so we teach multiple sections of introductory statistics class, along with more advanced statistics classes leading to statistics minor. And so basically, we use in the introductory statistics class, we use Introduction to Statistical Investigations by Alan Rosman and several others. And we use a different book for our more so-called intermediate statistics, which is Math 219. And that's was the class where I implemented my activity. So it's intermediate statistics. It uses different textbook called Introduction to Modern Statistics from Open Intro. And it roughly followed the same pattern as Introduction to Statistical Investigations in terms of the progression of topics. And so my topic was on analysis of variance, which essentially was an activity related to the data set on the changes in the percentage of brain shrinkage depending on different physical or social activities. And so because it's more advanced class, in addition to the handouts and the materials that we normally use in introductory statistics class, I also use things like Taki procedure and Bonferroni correction to just add more kind of more tools of analysis to the students. And so our kind of analysis was, so there was a previous activity prior to the brain shrinkage that we went through and kind of built the necessary terminology and sort of the ways we will calculate test statistics intuitively. And so we kind of went through that in a lecture format, but then I gave them, I was essentially giving them parts of the paper that this study, this activity was based on. And I was asking in class kind of work with me on basically developing a null and the alternative hypotheses and how that makes sense and what we're trying to analyze here. We went through the sort of the steps of the building the more intuitive statistics based on the average means and the difference of means. And I was asking, like, based on what you have in calculations to that statistics, which of the differences, which group do you think contributed to the difference the most? So I was kind of trying to, along the way, they were working in groups. And so they were answering these questions. And then we use RStudio to run the analysis. So they ran the analysis and sort of we actually asked them to build the appropriate graphs and F distribution and stuff like that. So they were visually kind of following the steps of the analysis, and then I let them kind of read the rest of the paper, and they were kind of pleased with the fact that what they were following in the class was parallel to what the published article was following as well. So they felt much more justified in what they saw. That's a peer-reviewed, published material. And so they saw that the step that they were performing, they're exactly the ones that you expect from the field researchers. And so it went very well. There were actually the fact that they had real data on quite interesting topic. And sort of we had some previous discussion on kind of, some diseases related to aging and the lack of different activities. And so I even asked them, what do you think among the activities mentioned in the module, which one do you think will be the most significant ones? And so then we were following up whether their intuition was correct or not. And so the fact that they were working with real data and they actually had to completely build the analysis from the ground up, sort of kind of just this is the data, this is what they want to know, and sort of they had a free kind of a free hand in this approach. So I think it really worked well, and the fact that they were sort of mirroring the same result that the published article had reinforced and made them more confident in their knowledge.
Thanks very much. So our sixth and final panelist to present today will be Ashley. Please tell us about yourself, your school, your class, and the activity you implemented. Ashley.
Sure. Hi, everyone. I'm Ashley Mason from Lone Star College. We're north of Houston. We have about 8 campuses north of Houston and the surrounding area, and just our campus alone has about 15,000 students. At our campus, we only offer one stats class. We're primarily 2-year. We are starting to offer some 4-year degrees, but we have one elementary stat class that we get to pack all the fun into. And so this semester I had an online asynchronous elementary stats course that I implemented the paired data project in. And I think it went pretty well. Students usually do projects in our stats classes. So me and maybe 3 other faculty teach stats. And we try to implement projects. This is the first time I've used a simulation. And so I think students liked it. They had a chance to kind of visually see a sampling distribution being constructed, which is not, something they can see easily in a textbook. So I think they understood that a little bit better. The challenges. So my question is, did you encounter any challenges with the implementation? Not too many. So I made a video going over the project before publishing it. And then we had already covered 2 sample hypothesis testing at the end of the semester. So they had already done their homework associated with that section. Of course, the only thing I can think of challenge-wise is the use of AI. So, for students, sometimes if they don't realize that they can AI a project. So that's what I kind of like about the simulation is that when students try to throw the entire assignment into AI, it's not going to give, correct answers because you have to use the simulation in order to get the statistics. So I wouldn't say it's not the majority, not even half, probably out of 25 students, I would say 3 or 4 where I was reading and it was saying, you know, to find the p-value, you would have to do this, and then I have to have a separate conversation with them about it. But I think making the video and walking them through the applet, it was simple enough for them to understand how to use it.
Great. Thank you very much.
Mhm.
Before I open it up to questions, let me ask if any of the panelists want to say something they didn't already say. If you were sort of waiting till the end to offer something, or if you thought of something you want to add, I'll give you a chance now before I open it up to questions. Sounds like no one's going to take me up on that offer. So let me open it up to questions from anybody. Questions to an individual panelist, general questions that you're happy for any panelist to respond to, reactions.
I don't have any questions, but I just want to say thank you for sharing what you did in your classrooms with us.
Stan Young, I'm semi-retired. I'm interested in how people do elementary statistics. That's why I jumped in on this. Resampling or simulation is a fun topic for me. I didn't hear from you guys what the simulation was. So if someone could explain that. Also, I picked up on the use of Bonferroni correct for multiple testing. So anyone that would respond on the sampling process that went on would be of interest to me.
Maybe someone who did the paired data activity could talk about the simulation process there.
I'll jump in. So the paired data, if you don't know the assignment, it was about whether there was this perceived notion of being more sweet from a pink carbohydrate rich solution in their runners versus a clear. And so they had runners, and they replicated the experiment where they put them on a treadmill and they ran for a certain amount of time. Yes. And I had to think about it. It's been a minute since I've done this. And they did it on the pink, where they had them rinse every 5 minutes, I think it was, on the pink. And then a week later, they had the same simulation. You couldn't do all this stuff before, and they had them run and do the clear. So we had the actual data from the distance traveled in 30 minutes for each individual with the pink and the clear. Then the applet, what it does, so it basically gives us an idea of, is this so unusual if it were compared to what if it was just random? And so it flips coins, it flips pennies to see, it takes the data, because if it was just random, then it wouldn't matter what color got what distance. And so it flipped a coin to assign the distance to a color, and then found the differences then, and then created the sampling distribution where the data was swaps, like the first individual may have been swapped or may not have been swapped, random selection about what the colors distances got swapped or not. And then it started them off at, I think, a simulation of one flip, and then it went up to what we did 1,000. And so it created a sampling distribution by taking the data and swapping it randomly for different individuals. And so you could see how our actual paired data compared to the sampling distribution, as if it were just random numbers, doesn't matter the pink or the clear. Did I say that well enough, Jill? Okay.
I followed pretty closely what you did. Did the students Had they seen this sort of resampling or done before, or was this the first time? What was their reaction to the empirical distribution that was built?
Well, in my class, we had already seen that. We had built the idea of a sampling distribution earlier in that unit. And so I think they realized they didn't understand what was going on with the pennies and the randomness. And then until they had done it several times, they recognized that we're building a sampling distribution, but they didn't understand where it came from. But they had this notion of the sampling distribution in advance, and I could say that for mine.
Thank you.
Well, I can speak a little bit about the Bonferroni correction and its implementation. So the Bonferroni correction is used in a added material because it's intermediate statistics course. So we don't have that discussion in introductory statistics course, but we have that more detailed discussion about it in the intermediate statistics. In both classes, we mentioned the fact that when the conditions are right, we sort of use the second stage of the analysis, the follow-up analysis or post hoc analysis, and where we actually analyze what are this, if the results of the test are significant, then we analyze which of the differences were actually significant. And so we discussed the fact that we have to take into consideration type 1 error. I mean, the whole analysis, the post hoc analysis, doesn't involve simulations. It's just the theoretical analysis based on the F statistics and the confidence intervals, theoretical confidence intervals. But I think it's an important discussion to understand that it's just, I mean, in both courses, we discussed that it's not enough to just run the test by itself. We need to have a follow-up analysis, and what are the types of follow-up analysis that could be conceived, and what are the kind of the problems with just running a bunch of pairwise comparisons, and have to take into account the probability of type 1 error and how it builds up. So that's kind of, that discussion leads to the idea of the Bonferroni correction and running a bunch of pairwise tests.
I have a follow-up question on the Bonferroni. There's a huge controversy in science right now that many claims that are made in scientific papers fail to replicate. And one of the issues would be, did the original person making a claim ask a lot of questions, not do the Bonferroni correction, and then just write a paper on any p-values that's less than 0.05? Does that come up with any of the students?
Actually, interesting. I appreciate the question, because that's exactly the issue that comes up in this study when the p-value of the essentially the F statistics and ANOVA table produces a p-value around 0.03. And so when you, and that is a significant result, but it's not sort of super significant, so to speak. And so the paper kind of, we kind of discussed how valid or how how strict are conditions in order to satisfy the significance after the Bonferroni correction. So the formulas that lead to necessary adjustment for Bonferroni correction might look like a little bit too restrictive. So basically, they can make a lot of data look insignificant due to that pretty strict requirements of the Bonferroni correction. And so the paper itself doesn't produce the Bonferroni p-values with the correction. They just kind of point to the significant results and then produce the just 95% confidence interval for those differences, confirming that these are significant differences. But if you run the same analysis using the Bonferroni correction, then that significance actually goes away. So that was, I think, for the students was very valuable discussion and about, potential, what things to watch out for, and kind of what are the sort of downsides and positive things about follow-up analysis.
Thank you.
Thanks for the question, Stan. Does anyone else want to jump in on the most recent question about reproducibility and p-hacking and topics like that?
I will introduce that a friend of mine and I have gone through maybe 70 papers, counting how many questions are implicit in the way the paper was written. The median number of questions that we came up with was on the order of 13,000. So there are a lot of questions, a lot of papers where there's a lot of freedom, as Alan says, for p-hacking. And in none of the 70 papers that we looked at was there any Bonferroni correction or any other correction. So it's a serious, serious problem.
These are papers in what field or fields?
We looked at nutrition. We looked at air pollution. We looked at do masks work? And then we looked at a psychological thing going on, implicit bias, which is the basis for DEI. And in all of those fields, we found a considerable amount of ability to p-hack.
Thank you. About a new question for the panelists, either directed to a specific panelist or a general question for the panelists.
I have a question for Kristen. You formerly worked at Hewlett-Packard. What do you find most different between working in industry, which is sort of driven to find things, and academia, where you're teaching people how to find things? What was your feeling between the two? I'm very interested in that. I always worked in industry. I never worked in academia.
Gotcha. Yeah. So in a sense, I kind of had the best of both worlds the whole time, if I'm being honest, because after my 4th year of grad school, my advisor was having a hard time advising me because I knew I loved teaching, but I also wasn't sold on the notion of working for a university. So I interned at HP and was on the West Coast for the first time in my life because I was, from the Carolinas and all that. But I was honest with him in my interview, and I told them, I love to teach, but I also want to get industry experience too, beyond like the climate office and stuff. And they're like, good news, you will teach at Hewlett-Packard and you will also do projects and stuff. So yeah, and that became a pretty significant part of my job. So like I would teach, design of experiments, data analysis, reliability, so survival analysis for engineers, all that good stuff. But I liked the fact that, nothing in industry was straightforward. There's always constraints, and the whole notion of IID observations out the window immediately. And you have to kind of assess, how sensitive are my results to these assumptions that I'm having to make, and then, kind of work on a very tight deadline. So whether the constraints were around like the schedule and the fact that, R&D can only last so long before you have to send it to manufacturing. And the fact that, testing costs a lot of money, especially in the tech industry, where some of our, devices have gold components and we're not trying to over test at all there. And yeah, staffing, all kinds of like real world constraints there. I like that because it's like, how do you optimize in those things? Well, you have to assess the importance of each of those components there. So I just like that piece of it. But one thing that I wish I could do that I couldn't in industry was that when I was teaching these classes to different audiences, sometimes it was chemists, sometimes it was engineers, sometimes it was like business analysts. Anytime that they're taking a class from me, it's time that they're not really working and, driving toward the bottom line in active time. So I basically would have 3 days to be like, here's all the stats, boom, let's go. Which means that it is a lot harder to take the time to develop the intuition behind some of those concepts and that kind of thing. So I had to be very intentional about, the things that I did spend time on, developing the intuition there. And then the other things where I was more like, okay, here are the mechanics of running this analysis and, yada, yada. So, and that's one thing I like about working in academia is that I have a whole semester to do that. I still can't spend forever, but like I have so much more time and freedom to explore, a bunch of concepts and a bunch of applications, so that when I get students from all kinds of different areas, not necessarily, physics or, engineering, I can work with all of them and show them how stats can be applied in their interest area. So.
Yeah, one follow-up question, if I might. Design of experiments, I think, is woefully untaught in statistics departments. So had you seen design of experiments before you showed up at Hewlett-Packard, or was that something you had to pick up once you were there?
I didn't have a formal class on it, but I had picked it up in other classes, like bits and pieces of it. So I went to NC State for my undergrad, and we had an industrial statistics class, and that had some aspects of it. It was, of course, more, engineering kind of statistics, but there were aspects of it. But a lot of it I did pick up on the job, and that was super valuable.
I'll just comment, Kristen. I graduated from North Carolina State, and it was a long time ago. It was a long time ago, but the department's name at the time was experimental statistics, and then later on they just went to general statistics. So it's very, very good that you were able to pick up some design of experiments. I find that has been one of the most useful things I've ever run into. Thank you.
Yeah, definitely. And I'm teaching, or I just finished teaching statistical engineering for the first time at Willamette, and I definitely dedicate a lot of time to DOE. So, yeah.
Let me ask my department colleague, Karen McGoy, to chip in on this experimental design question.
Oh, yeah. I was actually going to ask a question, Alan, but
Either way, floor is yours.
So yeah, we actually have at Cal Poly, we have a design of experiments course for our undergraduates. But in our second statistics course, we do a fair bit of DOE block designs and completely randomized designs. So even students in a second course are getting exposure to DOE. And I guess even in our first course, we, of course, like many people do, touch on random assignment and a little bit of experimental design. But I was actually going to ask a question to all the panelists. And some of you may have had more or less experience with this group and some of the modules that have been presented before and used as the basis for workshops. But I guess in general, based on your experience, would you recommend that others try the activity or the module? And so I guess that's maybe a backdoor asking way of asking if you liked it. But what would your recommendations be for other people who are interested?
I'll answer first if unless somebody else just really wants to. I would definitely recommend, I've done this a couple of times. Last year there was a set of activities, and I implemented one of those, and actually implemented it as well in this past semester because my students seem to like it so much. So I highly recommend being part of a team or a group and implement an activity. It gives you an opportunity to try something different, and just to see a topic from a different perspective than you probably have seen it, especially if you're not using the textbook, that the ISI textbook that Rossman and chance and all that it goes with. So I would highly recommend anybody who has the opportunity and the time to do the sessions on Fridays, watch the activities, participate in the activities to start with, and then implement them yourself.
Other panelists want to weigh in on Karen's question? You're allowed to weigh in even if you're not as enthusiastic as Elizabeth is about the whole thing.
No, I'm gonna
Okay.
piggyback. Oh, go ahead, Chatu.
No, you can go again.
Yeah, no, I just wanted to like echo what Elizabeth is saying. The students really enjoy it. I can't tell you how many times we've done a problem and it's like finding the mean length of a light bulb and you can just see like the life drain from their faces. And so if they're actually working on a project and they can actually see, like for the paired data, they were like really floored that they could see the clear distance and the pink distance and how they were linked together. And they could actually see the variability in the distances. And that's just something I don't think that they ever would have thought of if they were only seeing like a table of information. So, and then the other part, most of our students who are taking statistics are nursing majors or they do not want to take college algebra. So they'll be in stats. And they're going to see stats when they leave the class. Like I don't care if it's like the news or they're going to take like a business class next, but somewhere they're going to see standard deviation again. And so kind of incorporating like contextual projects gets them away from like memorizing everything and actually like thinking like, when am I going to use this outside of the class? I don't know if that answers the question, but I just was going off of what Elizabeth said.
Yeah, so for this time, I was teaching this class for the second time. For the first time, I used the ISIM book and I followed the same style, but for some reason, I couldn't finish it during the whole semester. So then I had to tweak it a little bit, like taking off little sections with the apps and everything. I just turned it to only R Studio stuff. So we did the simulation stuff through the R and everything like that. So with this exploration activity, I was able to give them that simulation experiment through the app. So it kind of like visualize what they're trying to do. I really like the way that this book flows on. It's really help the students to follow what they need to know. But anyhow, with the time consumption problem, I could not do that. But with this one, I was able to input a little bit of more interaction and also like the simulation stuff to them. So it was like not just working through the codes and stuff with R, but some sort of visualization. How does that flipping coin stuff work? And I think that simulation experiment was the best one I did during the class time for this particular semester. So thank you, everyone. I really recommend this one.
Thank you. We have about 5 minutes left if there are more questions or comments or reactions.
I just want to make a comment, I guess, or whatever. Laura, go ahead. Sorry, go ahead. Okay, so one thing I liked about this was that, whenever, at least when I was going through, my undergrad, education, I would always think, I'm like, well, but this thing over here could easily impact that too. So I think a lot of students naturally think in a multivariate way. So like for us to have an open discussion and say, yeah, you're absolutely right. In this particular case, we might focus on this one X, this one covariate. But yeah, you're absolutely right. And it kind of like sets the stage nicely for, multiple linear regression and other multivariate concepts. So it was cool. And it also, it gives you a chance to delve into the notion of intersectionality for the ones that are more humanities leaning. Because as soon as you do some of the, just exploratory data analysis, you'll see some of those interactions. So, and that was like one of my absolute favorite things to talk about in this particular class. Because yeah, even with the example we did in that particular case, we were able to pull out some of that and how like, yeah, the state you live in, as well as maybe your religious affiliation might be, they might make you, they might play out in different ways, is just how I should say it. So it was really, really cool and a really insightful discussion. And some of my students who were double majors, data science and, sociology, let's say, they were like really, really into it. So yeah, I'm sorry, Laura. You had your hand up, sorry.
It's way more fun note to end on. But I did have a question for Ashley when you were saying that, not that it's AI proof, but that when students put it into AI, they're not getting like the right answers. And I tried that this semester too. And I just, like, how did you sort of operationalize that? Like, was it that they were writing about theory based, or like, what did it look like, I guess, when students tried to do that?
Oh, I mean, it's somewhat obvious in their responses. There's like a lot of technical language that we might have not have gone through in the class. And so I think if I use this activity again, I'm just going to tweak some of the questions so that they're a little more subjective. Like, I think one of the questions was like, why couldn't the study be observational, or what were some of the limitations to that? And I got a handful of responses were like, oh, it could be a confounding variable. And, you know, and like it would be very, very general. And so I think in the future, I might ask them like, what specifically, like what's a specific confounding variable, to kind of make sure that it's not something they're just regurgitating and they actually like understand like what's being said. So, but other than that, I mean, the first half of the project, I think are more general questions about the design of the experiment, but the second half uses the applet. And so again, like it'll ask what's the p-value. And so if students are just throwing it into AI, it'll say to calculate the p-value, you need to find, you know, this from your calculator or from Excel, when obviously we're using the applet. So yeah, I don't know if that answers your question.
Thank you. If you haven't noticed, let me point out that Jennifer Ward posted in the chat an activity that she revised into a Desmos activity, which is based on the memory activity that Karen presented on a couple of months ago. So please take a look at that link if that interests you. Well, I guess it's 1 minute till the top of the hour, so I should wrap things up. Thanks very much to the panelists. Let me point out a couple of things before you run away. One is that on January 24th, we will have another of these panel discussions among panelists who implemented one or more of these kinds of activities in their class in the past month or two here. So January 24th, 3 p.m. Eastern, 12 p.m. Pacific. We'll have another panel discussion very much like this one with a different set of panelists, a different set of people who tried out one of the activities in their class. I also want to say, and someone can correct me if I'm wrong, but I believe we're currently recruiting a new group of people to implement activities in the spring term and then join a panel discussion later in the spring term. And I think we plan to have another set of workshop sessions where some members of the team will present an activity, and then there'll be a chance for participants to try it out with their class. So can someone confirm I'm right that that invitation has gone out? You should have received an email, I think, from Nathan Tintle asking if you want to sign up to be a scholar, is the word we use, someone who implements one of these activities and then shares their experience. If you did not get an email message from Nathan and you're interested, you can send a note to me and I'll get you in touch with the information. Jen, did you post the application form in the chat, it looks like?
The link that I posted is the application form, and Beth just followed up with the link to get more information about the Scholars Program. So thank you.
Yeah, great. Thanks very much. I also wanted to say that we're in the process of creating a Google group, which we hope will be a more efficient way to send out messages of the type that you often receive from me about workshops and panel discussions and things. I'm not sure what the details are for that, but it looks like maybe something was just posted in the chat about that. In the short term, yeah, Beth just posted a sign up for the Google group message in the chat if that interests you. If you want to keep receiving BCC messages from me, we'll keep doing that for another few months. But eventually we'd like to go to a Google group where people can unsubscribe if they're sick of hearing from me on their own and things like that. Anything else I should say? Any other announcements anyone wants to make? Thanks very much, certainly to the panelists, but to everyone for being here. I hope you all have a academic break coming up, and I hope you find it relaxing and refreshing, and have a wonderful holiday season, and take care. Thanks for being here.